Hello everyone, welcome to Eduxcite classes. My name is Monit and in today's session we'll continue from the last video for A.2 forces and momentum. In this we will discuss mainly about the impulse and linear momentum in one dimensions. Okay, in the next video I will try to cover the principle of conservation of linear momentum and the collisions in two dimension or the conservation of momentum in two dimension. This video is quite important, the reason being the choices of the question which I have included in this video will help you to analyze how momentum can be act with respect to change in the mass as well as change in the velocity. Okay, so let us start with the very first. These are the formulas which are given in the data booklet. So before moving on, make sure that you share this video with your friends and the classmates so it reaches to the masses. Also, you can find out the PDF of this video. The link is given in the description below. Okay, so let us start with the very first question. You can also solve with me. I will give you the time to pause. So this is the question number 1. Pause the video and solve. Okay, so in the very first part we have to find out the change in the momentum of the pallet. So we know that the pallet has initial speed of 180 meter per second. The mass is given, and when it gets inserted into the clay block, the velocity will become 0. It will be at rest. So the change in momentum I can write mass times V minus U. So mass is 2 into 10 raised to power minus 3 to convert into kg. Final velocity is 0 minus initial is 180. So when you do this calculation, you will get 0.36 Newton second. Okay, so you can do the calculation. It will be negative, so the negative just denote that it is the loss of momentum because the velocity is decreasing. So this will be the answer for the A first part. I hope it is quite clear. Now the A second part, the stopping time of the pallet in the clay block. Now how much time it will take for the pallet to stop inside the block. Okay, so we can use this change in momentum will be equals to your, so the force is given to us, right? So using the force I can write force is equals to mass time acceleration. So F by m will be my acceleration. So F is 750 Newton, mass is 2 into 10 raised to power minus 3. So this you will get something around, I have already done the calculation, this you will get 375 into 10 raised to power 3 meter per second square. So this acceleration will be quite very high, the reason being it will stop within a fraction of second. So this will be your deceleration. So assuming this as the constant acceleration, I can use the equation v equals to u plus at. The final velocity is 0, initial is 180 plus acceleration is minus 375 because it is decelerating into time t. So using this equation, time t comes out to be 4.8 into 10 raised to power minus 4 second. So this will be your answer for the A second part. Okay, I hope it is quite clear. Now read the B part. Estimate the distance that the pallet penetrated. Again using the same, I can use V square is equals to U square plus 2AS. So you will get an idea like how the Survey equations can be used using the concept of the momentum as well. So in your exam you can expect such type of questions where you will using the Survey equation as well as the concept of momentum to solve a particular question. So you have to be very mindful while reading out the question. Stop final velocity is 0, initial is 180 square plus 2 times of minus 375 into 10 raised to power 3 times s. We have to find out that how much distance it will penetrate into the block. Okay, so this will, when you will solve, I have already done the calculation, it will be in centimeter, it will come out to be near around 4.3 centimeter, or you can say 0.043 meter. Okay, so you can do the calculation, you have the calculator with you. Now the C part, outline why the answer in B is an estimate, because we are considering, because we assume the acceleration as constant, as but in real it may not be. Not be the same. So you can say that it is an estimate, it is not the actual value. Okay, so I hope the question number 1 is quite clear. If you have any doubt related to any part, just comment below. Okay, I will try to resolve all your doubt. Now pause the video and solve question number 2. Okay. Now A, first part, calculate the weight of the ball. Now weight of the ball, if you have given momentum versus time graph, the slope of the momentum time graph is nothing but the force. So change in momentum over change in time is your force according to Newton's second law, and the slope for this graph will give you the weight only, because that is the only force acting when the ball is been dropped in air without air resistance. So this will give you 0.75 minus 0 upon time is 0.5. So the weight will be 1.5 Newton. So this will be your answer for the A, first part. Second part, the speed of the ball just before the impact. Now for the speed of the ball, if you want to find out, we can simply use V equals to U plus AT, because it's a free fall motion and acceleration due to gravity is, you can take G. So V I take 0 and downward direction is positive. Sorry, initial speed is 0. V we have to find out, plus 9.8 times. T is given that it is the point at which it will touch the ground, so it is 0.5. So if you do this calculation, you will get V as 4.9 meter per second will be the answer for the A, second part. Quite easy. Now the B part says that the ball is in contact with the floor. So from here till here, this is the time at which the ball is in contact with the floor, which is 0.1 second. We have to determine the magnitude of the average force contact between the floor and the ball. Now in this, you know that the change in momentum over this time will be the average force. So I can say F average will be change in momentum over change in time. So if you look at change in momentum, it is 0.5 minus of 0.75 upon 0.1. So this will give you 12.5 Newton, or you can say 13 Newton, rounding off into two significant figures. So I hope this is quite easy to understand. If you have any doubt, just comment below, and please share this video with your friends so that all of your friends and the classmate gets benefit, and even I also get some motivated to make and complete the series of the complete syllabus. Now pause the video for question number 3 and solve. Okay. Now if you look at these questions, these are very important from your momentum. Try to understand, there is a mass of 0.48 kg of water leaves a garden hose every second. So can I say delta M over delta T, that is the mass that is leaving the water hose every second, is 0.48 kg per second. Okay, this is per second. Now the nozzle of the hose has a cross sectional area of this, and the water flows in the hose at a speed of 0.7 meter per second. The density of the water is given to us. We have to find out the speed at which the water leaves the hose. Now try to understand one thing. Let us say this is the hose, and this is the volume V1 and this is the volume V2. Now the amount of volume entering will be equals to the amount of volume water exiting the hose pipe, right? So can I say V1, the volume is equals to V2, and volume can be written as the area of cross section into speed V1, and this will be area of cross section A2 times speed V2. So try to understand this thing, right? So, and volume can also be mentioned as mass per unit density, the mass of the water leaving per unit density. So I can say the area of cross section A1 into speed V1 is equals to mass delta m over delta t times divided by density of the water, right? So area of cross section is how much? 8.4. So we have to find out V1. So V1 I can say delta m is 0.48 kg per second divided by 1000 into 1 upon area. Area is directly given 8.4 into 10 raised to the power minus 5. So this will give you the speed at which the water leaves the hose. So I hope this is, let us say, V2, because this is the leaving part. V1 is given to us. This is V1. Area of cross section is not changing. So if you solve this, I have already done the calculation. It will be something around 5.71 meter per second. You can do the calculation in your calculator. You will get the same answer. Okay. If you have any doubt, please let me know. Try to understand this concept. The amount of water entering will be equals to the amount of water leaving. So, and this volume can be written as the area of cross. Try to understand, let us say this much amount of volume is leaving per second. So this is how much volume. This is the area of cross. How do you find out the volume? Area of cross section into length, and this length is the velocity. That is the length in 1 second is the velocity of the water flowing. So this is the length of the water, which is V in 1 second, because if I say speed equals to distance over time. So if time is 1 second and the distance will, magnitude wise, the distance will be equals to the speed in 1 second. So that is the concept I have used to find out. Do not get confused. Capital V stands for volume and small v stands for the speed. So always remember the volume flowing per second is equals to area of cross section times the speed of the water flowing through it. This you have to remember. Okay. So this is the answer for the A part. Now the B part says that the force on the hose. Now force can be written as delta m over delta t times velocity v, right? Now velocity v is the velocity or you can say the mass leaving per second times change in velocity. This is delta m over delta t. This is the mass leaving per second times change in velocity. So this is 0.48. Now 5.71 is the leaving and initial velocity is 0.71. So if this value you will get, I have already done the calculation, this will be something around, so the force is 2.4 Newton. So I hope this is quite clear. So this is quite important, guys. Make sure that you remember how to find out. The force will be mass times change in velocity. So rate of change of change in velocity into delta m over delta t, basically, right? So this will be the average force that will be exerted on the hose. Now pause the video and solve for question number 4. Okay. Now if you look for the A part, again the speed of the water in the hose. So I can say A1 V1 is equals to capital V, right? The same we can apply here. Now here what is given in the question is the diameter is given, so we can find out the cross, because if you see the cross sectional area, it will be a circle and the area of the circle is pi r square, right? So area of cross section we can find, velocity we have to find out, so I can say the volume of the water leaving, and 1 liter of water is equals to 1 into 10 raised to power minus 3 meter cube in volume. So this relation you should know for the water, that 1 liter of volume takes up the space equivalent to 1 into 10 raised to power minus 3 times of meter cube. Okay, so this is the volume of water flowing per minute. So I can say the volume upon area. So this volume is 9 liter per minute. So in second it will be 9 by 60, and to convert this into meter cube, it will be into 10 raised to power minus 3. So this is the volume in kg per meter cube. Okay, sorry, in meter cube per meter cube, and area of cross section is 1 upon pi r square. So this is the diameter, so radius will be 7 and meter it will be 7 into 10 raised to power minus 3 times square. So this will be your speed. So if you calculate this, the V1 comes out to be, I have already done the calculation, it will be 0.97 meter per second. So this will be the speed of the water in the hose. Now read the next part. The cross sectional area of the nozzle of the hose is 12 times smaller than the cross sectional area of the hose itself. So one is the hose and then it is a very smaller cross sectional area, that is the nozzle of the hose. We have to determine the change of the momentum of the water leaving the nozzle in 1 second. What will be the change in momentum? Because as the area of cross section decreases, the velocity of the water increases, that is leaving the nozzle. So what we can do here is, for the B part, I can apply the same, because the amount of water that is entering will be equal to the amount of water leaving. So the amount of water, the volume of water is, again I can use the same V to find out A2 into V2. V2 is the speed, that is for the nozzle, right? So that will be 9 by 60 into 10 raised to power minus 3 times area is pi 7 into 10 raised to power minus 3 square and 12th time. So area of cross section decreases by 12 time. So if you divide this by 12, this 12 will come to the numerator, so it becomes this. So this will give you the answer for V2. So if you put up the values, you will get V2 something around 11.693, or simply I can say 11.7 meter per second is the speed at which the water leaves the nozzle in 1 second. Sorry, we have to find out the change in momentum. My mistake. So change in momentum will be the mass times change in velocity. Okay. So mass times change in velocity. So mass can be written as density into volume leaving per second into change in velocity, which is V2 minus V1, right? Density of water is 1000, volume is 9 by 60 into 10 raised to power minus 3 in meter cube into 11 points, you can use 693 minus 0.97. So I have already done the calculation. You will find out that the change in momentum is 1.6 kg meter per second. Sorry. I hope this is quite clear. So this is how you solve the B part. Now explain why a force is needed to keep the nozzle of the hose stationary. Now this you can answer. Let me first write it down. Okay, let me shift a little bit up. So I'm writing down the answer here. Okay. So because of change in momentum, a force is exerted on the water by the hose. So you can refer the Newton's third law that the water is exerting a force. So the hose will also exert the same force but in opposite direction. So to keep the hose stationary, an external force has to be applied to balance the force that is being exerted by the water. Okay. So I hope question number 4 is quite clear. Now pause the video for question number 5. Okay. Now if you read out the question, the first part is quite easy. Calculate the magnitude of the lift force acting on the helicopter. Now if it is being rover, the weight will be equals to the lift force, right? So I can simply say the magnitude of the lift force will be equal to the weight, and the weight is equals to m times g. M is already given, times g is 9.8. So if you do this calculation, it will something around 29 kilonewton. Okay, so this is quite easy. Now they are given that the stationary air with a downward speed v. So this speed of the air which is pushing it downward is v. The surface area of the rotor is 95 meters square and the density of the air is given to us. We have to show that the mass of air pushed downward per second is rho a v, right? So this is very easy, we have already done. So the mass of the air which is pushing downward, so can I say that density is equals to mass per unit volume, right? So mass can be written as density times volume, and volume can be written as area of cross section into speed v, that I have already discussed in my previous questions. You can go back and check once again if you haven't gone through it. Okay, so this is the speed at which it is being, so in this question it is given v, and this is the volume of air. So do not get confused with the notations of capital V and small v. So if I put this in, so I can say the mass of air pushed downward, will be equals to density times area of cross section times speed v. So this is I have already shown. So now we can say the mass, we have to calculate the speed v, right? So here still it is hovering, so I can say the weight, that is 3000 times 9.8, that is the weight, is equals to the mass of the air pushed into v, so rho a v times v. So it will be rho a v square is equals to you can say this is 3000 times 9.8. So v will be equals to, just put up the values, into 9.8 upon 1.2 is the density of the air times area is 95 and under root. So this will comes out to be 16 meter per second. Why? The reason being the weight is equals to the force, that is, this is nothing but the lift force, right? So lift force is the mass of the air pushed down into velocity, that is the mass of the air pushed down per second times velocity with which it is pushing down. So this will be equals to your weight, and therefore you can calculate the speed. Now the D part says that air is now forced to move with a higher speed u, so that the helicopter ascends with an initial upward of 1.2 meter per second square. Now the net force is there, so I can say that 33,000 into 1.2 is the net force. This net force is equals to the change in rate of change in momentum. So rho a v is the mass times change in momentum will be this we have already calculated. So let us say v dash is the new velocity or u is the new speed. So I can say u minus v. I hope it is quite clear. So, this will be the change in velocity, and this is moving with new velocity u. So this will be the mass of the air which is pushing downward now, and this is the change in velocity. So this is the change in rate of change in momentum as a overall. So I hope it is quite clear. Now if you put up the values, density is 1.2, area of cross section is 95 u, so this will become u square, and let us take this as 16, so this will be u square minus 16 u equals to 3000 times 1.2. This and this gets cancelled, so this becomes a quadratic equation, u square minus 16 u. This will go to division of 3000, and this will become, I have already done calculation, 31.58. So u will be coming around 17 meter per second, or it will be 16.58 something or something like that. So it will be overall 17 meter per second. So I hope it is quite clear how to solve such type of questions. If you have any doubt, just comment below. Now pause the video and solve question number 6. Okay, now estimate the impulse given to the ball. Now whenever the force versus time graph is given, the area under the graph will be nothing but the impulse. So just to estimate, because it is a curved line, so the area under this curve, if you find out, I use the half base into height. So the impulse will nothing be, I can write it down here. So the impulse will be area under the curve, so that is equals to half 24 into 10 raised to power minus 3. Do not forget this is in millisecond, times height, which is 200. So if you do this calculation, you will get the answer something around 2.4 Newton second to the left, because the ball is moving towards the right. So after it hits the racket, it will move towards the left. So this is like this, it is hitting like this. Okay, so A is, because you have to answer with the direction. Now for B, calculate the velocity of the ball after being stuck by the racket. So impulse is nothing but change in momentum, right? So we can find out the first change in velocity, which will be impulse upon mass. Impulse is 2.4, which is towards the left, so it can be written as negative, because I am taking the right hand side as positive, so left hand side will be negative. So mass is 57 into 10 raised to power minus 3, right? So this will give you change in velocity, and this change in velocity comes out to be 42 meter per second in the left hand side. So minus 42, and V final we have to find out, minus V initial. Initial is 24 towards the right, which will be positive. So this is final minus initial. This minus is final minus initial, and this initial is positive only. So this is plus 24, and this is negative because of this. So do not get confused. So V final is minus 42 plus 24. So V final comes out to be minus of 18 meter per second. That is nothing but towards left. So it is quite known as well that if it has been hit in the opposite direction, it will move in the left hand side. Okay, now you can answer for the C part. The ball is stuck with the same force with different rackets. Explain why a racket with looser string could return the ball with greater speed. Now we know that if the force is constant, right, and impulse is denoted by J in your data booklet, so F times delta T. If the force is same, therefore if the ball is stuck with the same force with different rackets, explain why with a looser string could return in a greater speed. Now this will also be equals to change in momentum. So if force is same, right, therefore delta T, the impulse is same, so delta T will increase. If the spring is loosened, the delta T will increase. The ball struck with the same force with different rackets. Why a racket will looser string? Because the looser string will increase the point of contact time. The contact time will increase. As a result, the momentum will increase, and if the momentum increases, the ball will be moving at a greater speed. So that you can frame in a sentence that the contact time increases, as a result momentum increases, as a result speed increases. Okay, I am not framing as sentences for this time consideration. Now the D part suggests a disadvantage of playing a tennis with a racket with looser string. So if the speed increases, there will be less, because there will be less control over direction. So most of the time your ball will move out direction. So I hope I tried my best to explain this question. Make sure you do the questions on your own first. Pause the video for question number 7 and try. Yeah, this is quite easy. So the horizontal force will nothing but change in mass over time times velocity. So 40 kg per minute per second you have to consider, into velocity is 9, so this will be nothing but 6 Newton. So this, guys, always remember, momentum is not only the change in velocity due to change in velocity, but it can be due to change in mass. So that is the reason I made the video separately for impulse and momentum, so that you get a better understanding how to use the equations related to the when there is a change in mass and when there is a change in velocity, and some questions related to the graph. Now moving on to the MCQ part, paper 1. Pause the video for question number 1 and solve. Okay, yeah, so magnitude of force F is nothing but change in momentum over time, that is the slope. So this will be nothing but 200 divided by 10, which is 20. Option C is the right answer. Quite easy, believe you can do it. Now solve the question number 2 and 3 in one go. These are quite easy. Okay, yeah, the impulse given to the body is equals to the change in momentum. Option D, directly given in your data booklet. Now net force of F acts on a body for a delta t time, producing an impulse y. Which of the following is the magnitude of the rate of change of momentum of the body? Guys, this is asking you the rate of change of momentum, which is nothing but the force only. Change in momentum is impulse, but the rate of change of momentum is force. So option A is the right answer. Okay. Now question number 4, pause the video and solve. Yeah, again the force versus time graph. The area of the force versus time graphs gives you what? Change in the momentum of the body, because F is equals to delta P over delta T. So F times delta T will be change in momentum of the body. So area is always the multiplication of the terms. So y-axis and x-axis. So option C is the right answer. So these are quite easy. Now the last question of the video, please solve. Pause the video and solve. Okay. Yeah, so the F maximum will be the change in momentum over time. So you can say the change in momentum or the force maximum. So the force is acting from almost, you can say 30 to 70 for a rough calculation. So 70 minus 30 is 50. So change in momentum is 10 upon 50 into 10 raised to the power minus 3. So it will be 10 raised to the power 3. So this will be 10 by 5 into 100. So this will be 200 Newton. So option C is the right answer for question number 5. Okay, so I hope you have gone through each and every question. I hope you like the video as well. All the questions I tried my level best to explain you. Even though if you have any doubt, please comment below. And it's a small request to please share the video as much as you can with your friends, with your classmates, with your teachers if they need to get an idea. And keep learning with me. See you in the next video. Take care. Bye bye.